This problem is asking you to sketch the graph of a rational function following a bunch of steps. So the rational function that we are trying to graph is f of x equals to x minus 4 over x minus 7. The first problem is asking me to find the domain of this function. It's not that hard. I can see that every time I see rational functions, the first sentence that show up in my mind is no 0 in the denominator. So this denominator cannot equal to 0. So that tells me x minus 7 cannot equal to 0. So therefore x cannot equal to 7. The x minus 4 on top, x can be anything you like because it is okay to have a 0 on top, but when x is equals to 7, the function is undefined. Everything is messed up when x is equals to 7. Okay, and then I will just draw a number line, and then this number line stands for x, and then no 7. So x can be anything you like. So when you select an x value, I will say, okay, pick anything you want, but no 7. Okay, so we punch a hole at 7. So note that, and then x can be anything greater than 7. X can be anything less than 7. Oh, for the number line, what is on the right hand side of 7? You have numbers greater than that, like 8, 9, 10 numbers greater than that. And then on the left hand side, you have a 6, you have a 5, you have a 4, and then 3, 2, 1, 0, negative 1, negative 2. So basically big numbers on the right, small numbers on the left. So that is the number line. And then the interval, that will be from negative infinity to positive 7, from 7 to positive infinity. And then the inequality will be for the first interval, that will be x less than 7. The second interval will be x greater than 7. And then you earn your 2 points. I will say basically they only ask for inequality or interval, right? I will just show this. Hold on. I will just box this to earn my 2 points. There you go. I just earned my 2 points. And then the next one is asking me to find the vertical asymptote, which is very easy. What's x cannot equal to? X cannot equal to 7. So the vertical asymptote is x equals to 7. So when x is equals to 7, the function is undefined. So that is my vertical asymptote. And then the horizontal asymptote, you have to look at the highest degree of x. So the top has an x, the bottom has an x. They are both raised to the first degree, right? So that means the top and the bottom, they both have the highest exponent of the numerator is equals to the highest exponent of the denominator. So therefore, the horizontal asymptote is the leading coefficient of the numerator, which is this one, divided by the leading coefficient of the denominator, which is that one. By the way, the coefficient is the number in front of x. So that is a 1, that is a 1. What is 1 divided by 1? Which is equals to 1. So we will just write that y is equals to the leading coefficient of the numerator divided by the leading coefficient of the denominator, which is just equals to 1. So the horizontal asymptote is y equals to 1. So you know what? When we graph that, can we use a different color to do this? Because I want to like give you a better picture on the graphs. Okay, I just earned my 4 points. And then the next step is they gave me a table and then asked me to determine the asymptotic behavior of the vertical asymptote and horizontal asymptote. All right, I can do that. Where is my 7? I don't see it, so this is 7. Oh, I think that is the reason. When x is equals to 7, y is undefined, and they don't want to give you a hint in part C to answer part B. So 7 is just right there. This is a number that is a little bit on the left hand side, or I should say a little bit less than 7. This is a number that is a little bit greater than 7. So when x is a little bit less than 7, wow, y is negative 299. So that is like negative infinity, right? So the graph drops all the way down. When x is equals to positive 7, y is very large. Okay, as x approaches to 7 from the left, so that means if I do a 6.9999999, and this will be negative infinity then. Okay, so as a result, when x approaches to negative 7 from the left, y approaches to negative infinity, because this number is negative and very large. And then on the other side, as x approaches to y, 7 from the right, and then this will be positive very large, which is positive infinity. How about the other two, as x approaches to negative and positive infinity? Okay, so let's state the function one more time. The function is, let's do this in a different color. So f of x, the horizontal asymptote, right? So that one, I can do this in orange. So the function I got is x minus 4 divided by x minus 7 when x is infinity. So this will be infinity minus 4, infinity minus 7. A very large value, minus 4, minus 7, you still have an infinity over infinity. So you still have an infinity over infinity when x approaches to plus or minus infinity. So therefore, the way we handle this is, let me copy this one more time. And then I'm going to ask you a question. Hey, for the denominator, what is the highest power, exponent or degree? You will say, well, that is the first degree. All right, so we are going to do this. I am going to multiply the bottom by 1 over x. The top is also 1 over x. What that means is, once you distribute the fraction to top and bottom, I am trying to divide each term by x raised to the first power. Why is that not a second power or a third power? Or what if this is a third power? If that is a third power, then this is a third power, this is a third power. If that is a 13th power, then this is a 13th, this is the 13th. So that is depends on the denominator. So since that is a 1, I will stick to a 1. So back to my orange color. So I have x divided by minus 4 divided by, and then over x divided by minus 7 divided by what? The red x. Okay, red x, red x, red x, red x. Reduce that, so you have 1 minus 4 over x, and then over 1 minus 7 over x. So this is a magic. Once x goes to infinity, positive or negative, I don't really care. 7 over infinity. You take a number 7 divided by a very large value. So let's say you have a 2 divided by 6 million. What do you get? 2 divided by 6 million. The answer is very, very small and very, very close to 0. So this is very close to 0. So let's say 1 divided by 8 million. You have 1 apple. You want to cut that apple into 8 million pieces. How big is each piece? You can't even see, right? It's so small, so nearly 0, but not exactly 0. So I would just say this is a 0, that is a 0. Not exactly 0, but extremely close to 0. So 0, 0, and then you have what? And then you have 1 minus 0, 1 minus 0, and that is equals to 1. I would say that is true for positive or negative infinity. So 7 over negative infinity, 4 over negative infinity, so they are nearly a 0. Okay, so they are nearly a 0. So that means as x approaches to negative infinity, y approaches to 0. As x approaches to positive infinity, y approaches to hold on, sorry, not 0. This one, sorry. This one, what is the 1 mean? The 1 means as x approaches to positive infinity, y approaches to 1. Y approaches to 1. Okay, 1. Y approaches to 1. And then what does that mean? That means this conclusion is telling me that the horizontal asymptote I usually use HA. H for horizontal, A for asymptote, which is y equals to 1. So y approaches to 1 and y approaches to 1. All right, so I believe the next page will be asking me to just graph all of them, right? So we have, what do we have so far? We have a vertical asymptote at 7, a horizontal asymptote at y equals to 1, and x cannot equal to 7. I believe the next page is the graph. Yup. So graph the given function. For your convenience, I got the x-intercept and the y-intercept. Good. And then credits will be rewarded based on the following criteria: vertical asymptote, sketch, label, horizontal asymptote. Yeah, I can do that. I'm not going to miss a single point. Okay, on the previous page, we got that the vertical asymptote is x equals to 7, right? Okay, let's graph x equals to 7. So that is in pink. I'm going to do that in pink. So this is my vertical asymptote. So that is x equals to 7. And then what about the horizontal? Y equals to 1, right? Okay, so that is, there we go. That is y equals to 1. That is my horizontal asymptote. And then the other one is my vertical asymptote. There we go. And then what else? What else? What else? The x-intercept is 4, 0. So the x-intercept is 4, 0. I want to use a different color to do the graphs. Let's use this purple. So 7 and then 4, 0. I will say that this is a 4, 0. So that will be a 4, comma 0. And then what else? What else? I have a 0.57. Okay, so x equals to 0. Y equals to 0.57, so that will be 0, comma 0.57. Okay, I got my x and y. So that is my y-axis, that is my x-axis. So as x approaches to infinity, let's check. As x approaches to 7, not infinity, 7 from the left, y goes to negative infinity. From the right is positive infinity. So that means as x approaches to 7 from the left, y goes all the way down. On the right hand side, y goes all the way up. And then I also said that as x approaches to positive infinity, y approaches to 1, x approaches to negative infinity, y also approaches to 1. Okay, y equals to 1, then that will be this. Let me just do this one more time. That will be this. So the curve is so close to y equals to 1, but will never touch y equals to 1. How about the going up and down? Why this curve is getting closer and closer to 7, but will never touch or go across the vertical asymptote. This piece is getting closer and closer to x equals to 7, but will never touch, intersect, or go across the x equals to 7. And then the other piece, as x approaches to negative infinity, y approaches to 1. So getting closer and closer to the horizontal asymptote, but never touches the horizontal asymptote. Did I earn all the points? Yup, I plot the vertical and horizontal asymptotes, I label them, I got the x and y intercept plot and label. Okay, I think the last thing that I need is I need to write down that these two purple curves represent f of x equals to the given function. So x minus 4 over x minus 7. So that will be it. I should earn my 30 points. Okay, so that is the end of this video. Hopefully this problem save you some points, save you a big grade. If you like it, subscribe to my channel, give thumbs up to this video. I will see you all in the next one. Signing out.